Now the hardest part about this whole thing has been getting these sheeple to take their medicine. You know, they don't want to take the medicine, they don't want to swallow the truth. You know, something's got them spooked, man. Now I know the truth is hard to swallow. And these sheeple, they got the water now. They got the water. I gave them the water. So now they can start loving their planet. Think about that. But they got to keep their cool, man. These sheeple got to keep their cool because they're going to need electricity. And I'm going to show these guys how they can get the electricity right out of the garbage. An endless amount. No, it's easier to get than the water. So we're going to be able to get AC and DC right out of the trash. I'm going to show you how you can use these microwave parts, yeah, to generate electrical power. This is really easy, guys. So that's what this video is about. We're going to cover a lot in this video. It's a stormy night and it's raining outside, and these sheeple, the water's coming right down on top of them. So it's easy to get to the electricity. The entire planet, you're basically living on a big globe of electricity. That's what all the lightning bolts are all about. Think about that. So if we generated a lot of DC power, and today I'm going to show you how to generate some AC power. We're going to make some sine wave. And what we're going to use is that motor that's in the bottom of these microwaves that people throw out. So what we're going to do here, these microwaves have a lot of parts inside there, and you got to know what you're doing and how to use them. So I usually take the main transformer and I cut out the secondary so I can have my own coils and make a low voltage transformer. I like to turn them into about 12 volts. Then I add my bridge rectifier. See, if you use a small transformer like this, you can just use a diode and switch it right over to DC square wave. Let me show you what I did here, how I hooked this up. See, I took this motor apart. There's the microwave motor that's in the bottom that spins the plate. So it's 21 volts AC. That's pretty good. And this is what I came up with here. I just hooked a DC motor up to it. You know, I mounted it to the side of this board here, and then I put the belt on there and tightened it up a little. You know, I cut the top off and then I cut the side out so my belt will go through there. See, I hooked up my DC pulse width modulator. So I got some other fans here I took out of some other microwaves. Those are the AC fans. That's an AC motor. See, and the copper is very important. It's very important when you're using copper. It's one of the most important elements on this table of elements. Another precious element. You'll find it right there in between nickel and zinc. Like I said, I'm just going to keep making these videos. They may seem a little strange sometimes, but I do this so you guys remember. You know, I wanted to make a different channel instead of seeing the same thing all the time. But we're going to cover a lot of stuff. We're going to talk about the pulse width modulator. I got one right here. These were some original design schematics for my reactors. I found this in my file cabinet. You know, this is how I make this stuff. I just, you know, sketch it out before I build anything, you know. You gotta come up with something. See, I got my PC power supply here. Let me show you how this works. See, I got it running. I got it going to the DC motor controller. See? There's my wires and it's connected, and I'm gonna use it to generate some AC power. Let's turn this thing on. So we'll crank this up a little faster here. We'll get it to run full speed. We'll see if we can get 12 volts out of it. Get it going. You usually have to give it a little push sometimes. Okay. It's So I'm just using a rubber band. Here we go, we got 5 volts coming in. Let's speed that up. Let's see what we got here. Oh, there we go. Let's take it up. Let's take it up 12 volts. There we go. She's cruising now. Check her out. And if I wanted, I could take a transformer and step up the voltage. That's one of the things you can do with AC, with alternating current. You can use transformers to step the voltage up or step it down. And if you want, you could take a diode or a bridge rectifier and go right back over to square wave. You know, you can go right back and forth. It's very simple. You know, that's one of the good things about HHO and having a wet cell. The electronics are very simple. See, and I could leave this thing running day and night. I take care of it. See, and I have a constant 12 volts AC coming in. It's very steady, it's very stable. So you do that through the pulse width modulator. So we'll make some more videos in the future, but I just wanted to put some of this together to show how you could use these microwave parts and make a tremendous amount of electricity. Day and night. Very simple with the motors, pulse width modulator, power supplies, solar panels, batteries. We're going to use the AC fan here, and I'm going to spin the DC motor. Watch this. This is cool. Check this out. This is another way to get electrical power from these motors. A lot of people don't know what to do with them. These fans that are inside the microwave. See, I can put a belt on this one and spin things. I can spin a DC motor using a belt. See, and right here's an AC fan motor, and I'm going to plug it in. So I get everything in the open here. You don't want to get hit. Wow, this thing's powerful. And it pulls very little electricity. Look how little electrical power it pulls. See, 13 watts. Like a quarter of an amp. So it ain't nothing to it, but it gives off a huge amount of power. See, and I could take my DC motor that's connected to this fan right here, and see I have it hooked up to my power supply, and just stick it over this thing. Get a little room here. So you can easily get this spinning. You see the power coming in right there. So using one motor, one system to spin another to make electrical power. So there's lots of little tricks here. I'm gonna cover as much as I can. But you get this stuff out of the garbage. It's free. The electricity's free. It's easy to get. There's nothing to it. I mean, it's everywhere. So it's very important to be able to generate both sine wave and square wave electricity, and to be able to jump back and forth between the two when you want to. And with sine wave, you can use transformers and transistors, and you can jump back and forth with a bridge rectifier or a diode depending on how high the voltage is. So I'm just running a real low voltage here. I have an AC current coming in steady. See, and I can adjust that. Let's speed it up a little bit here. Let's speed that up. There we go. So I just used the JB weld. That's what I did here. I took the JB weld and I stuck the little pulley on top of that. You can see I had to get creative. You know, I cut the top off, and these little magnets, they come right out. You can see the magnet. That's what creates the magnetic field. That's what cuts the field lines of that rolled up copper coil that's in there. So it's super important to be able to do this, to be able to generate small amounts of electrical power. Because like I said, it doesn't take anything to get LEDs running. Stuff like this, we'll cover it. We'll be able to get all the lights on. It takes very little electrical power, very little. We'll be able to go switching back and forth between AC and DC using clever tricks. Use the microwave junk. You can get all the electricity you ever dreamed right out of the garbage. An infinite amount of electrons. It's as abundant as the water. So my little DC motor there is doing its job. It's pumping out that AC electricity. It's spinning that turbine. One of the most important elements, copper. Read this. Very important. I mean, you're not going anywhere without the copper. There's no way you're getting to Mars. There's just no way. You're going to need the copper. It's one of the most important elements. Think about that. You can find it right over here on the table of elements. You know, this is every known atom in the universe. It's sitting right there in between nickel and zinc. It's number 29. That's its atomic number. So if you look at what's going on here, I have it coming in the wall here, a sine wave. It's being converted over to DC square wave with my PC power supply. Then it's going to the pulse width modulator here. See, there's capacitors, transistors, resistors. You know, on the front here you have a potentiometer. See, that's going into my DC motor. And I'm using the DC motor to spin the AC motor to create the AC sine wave that you see coming in here. See, it's nice to have those DC motor controllers. It's really nice. You can create a very steady current in your power plants. So there's more to cover. Like I said, I'm trying to squeeze as much as I can in these videos. You see how diodes are used? How I can take that AC current and switch right back over to square wave again if I wanted to. I could use a diode or a bridge rectifier. So this was just a short video to cover some of the parts in the microwave. We'll cover more, but it is all about jumping those waves and jumping back and forth